get started. Welcome everyone to Why Was nerdctl made by Akihiro Suda today. Please put any questions you have in the Q&A, and Akihiro, please go ahead.
Hi, I'm Akihiro Suda from NTT Corporation. In this session, I'm going to talk about why we made nerdctl. Nerdctl is an acronym of containerd CTL, containerd nerdctl has the same CLI design as the Docker CLI. So basically, you can just set alias Docker equal nerdctl. But nerdctl is not just yet another clone of Docker. We made nerdctl for the sake of facilitating new experiments in the containerd platform. And simultaneously, nerdctl covers production use cases too. So if you don't want to enable the experimental features for production environment, you can just set export nerdctl underscore experimental equals 0 to disable these experimental features. Nerdctl is also useful for debugging Kubernetes nodes that are using containerd as the CRI runtime. I'll show you a demo. So nerdctl info, it's basically just like Docker info, and nerdctl dash help, and you can see a bunch of commands that are very similar to the Docker CLI, like nerdctl build for building container images, and nerdctl compose, and cp for copying files, and like push, and of course run, and like save, stop, and other bunch of Docker commands. Expect that we don't have a swarm command like Docker service, but basically almost everything is the same as Docker. And so like nerdctl run dash it rm alpine to run alpine container, and we have compose example like Docker compose YAML. And this is just an example of running WordPress with MariaDB or MySQL as a database. And we have nerdctl compose command. It's basically like Docker compose command, and run nerdctl compose up to run WordPress container and MariaDB container. It's just same as Docker compose. And here is the list of novel features for containerd and nerdctl. One of the features is that lazy print images with SBOM or Suda or Nydus or OverlayBD. These are alternative image formats that shortens startup latency of containerd containers. And we also have P2P image distribution with IPFS, so that you can distribute images without central registry. And we have image encryption with OCIcrypt, and also signing images. We support both Cosign and notation. And notation It's also known as notary v2. And we have real read-only mount with mount set attributes. So Docker has read-only mounts too, but Docker's read-only mounts are not real read-only mounts. I'll explain later, but Docker's read-only mounts are sometimes writable in a specific condition. And we have Slirp-less rootless functions with buffer spinach. So Slirp is the user mode TCP IP stack that is used by rootless functions. But nerdctl supports running root functions without using Slirp. So it's very faster than buildg Docker and buildg Postman. And we also support interactive debugging of Dockerfiles with buildg. Buildg is something like GDB debugger, but made for Dockerfiles. And so we have a bunch of novel features, but most of these features are still experimental, and these features still need more feedbacks from the community. So let's take a look at these experimental features. And one of the features is lazy print. It's a technique to pull image contents on demand. So you don't need to pull entire images, and you can run containers just in a few seconds without waiting for Docker pull commands or nerdctl pull commands to complete. This is not possible with the current OCI version 1 images. So several new image formats are being proposed to support lazy print. The most famous one is Stargz. Stargz optimizes Stargz so that the archive can be ticked with HTTP range requests. Stargz is forward compatible with OCI v1, so you can just run Stargz images with legacy Docker Postman Kubernetes or whatever. But to enable lazy print, you have to use implementation with support for lazy print, like Cosign. And we also support SOCI format by AWS Lab. So SOCI is also similar to Stargz, but SOCI captures a checkpoint of Stargz decoder stage. So it's more compatible with the legacy OCI version 1 Stargz. And we also support Nydus. Nydus is an alternative image format. This is not compatible with OCI version 1 Stargz. And we also support OverlayBD. OverlayBD uses block devices as control images. So obviously, OverlayBD is not compatible with OCI v1 Stargz. And here is a benchmark results of Stargz. So, for example, running CCC container, the legacy range takes about 45 seconds. But with Stargz and some optimization, the time can be shortened to just 5 seconds. So it's about 9 times faster compared to the legacy OCI image format. And the result is similar for GraphFish and Python. And the next topic is P2P image distribution with IPFS. nerdctl provides experimental support for IPFS so that the continuity nodes can share the same image without depending on the registry. The command line form is like nerdctl pull IPFS CID. CID is a content ID of IPFS. So you can just distribute images without depending on the central registry, and this content ID not exchange images by themselves. And nerdctl also supports OCIcrypt for encrypting OCI image layers so that we can protect secret files inside image. But it should be noted that image config information such as environment variables are not encrypted. So OCIcrypt just supports image layer for encryption. And the command line is like nerdctl image encrypt, and you can push the encrypted image to OCI 3. And in understanding, you can just use nerdctl pull to pull and decrypt image using private keys and a specific key storing directory. And of course, nerdctl supports signing images too. But the signing is different from Docker's implementation. Docker CLI supports Docker Content Trust that is also known as Notary V1. But Notary V1 didn't see wide adoption. So nerdctl does not support Notary V1. Instead, nerdctl supports Cosign and also notation that is also known as Notary V2. And you can specify --verify equal Cosign or --verify equal notation in the nerdctl pull command. And the next topic is real read-only mounts. So surprisingly, Docker's read-only mounts are not really read-only. So suppose you run docker run -v /mlt /mlt /ro, but this doesn't really make /mmt inside container read-only. So the file system of the /mmt is mounted as read-only, but submounts like /mlt/usb disk are still writable. So this can be a security issue in some environments. So nerdctl supports RRO. RRO stands for recursively read-only mount, and you can use RRO with nerdctl run -v /mlt /mlt sorry RRO, and this is implemented using mount attribute read-only that was introduced in kernel 5.12. And the next one is Slirp-less rootless containers. So I guess most audiences are already familiar with rootless containers, and Slirp is a user mode TCP IP stack that is used in traditional rootless containers, and Slirp is pretty slow. And nerdctl supports bypassing Slirp by using techcomp IOCTL notif as FD. This is a feature to inject socket file descriptors from host so that we can just skip overheads of Slirp. And surprisingly, this is even faster than root for containers. So in this benchmark, in the root for containers, connecting the host from container can achieve 38.6 gigabps, but traditional rootless container can only achieve 0.452 gigabps. But with bypass monitoring, there is that can be enabled by nerdctl run dash label equal nerdctl slash bypass net equal 1. So bypass monitoring can achieve more than 41 kbps. So surprisingly, it's even faster than root for containers because we can keep the entire network stack, and just we can just inject straight the file distributor from the host into the container. And the next one is nerdctl builder debug command. This is an interactive debugger for Dockerfiles that allows setting breakpoints just like GDB. And in these breakpoints, you can execute shell commands to inspect the current file system of the container. So in this example, you can use the break3 command to set the breakpoint on the line 3 of the Docker file. And when you reach the breakpoint, you can use exec/bin/sh to execute a shell to debug the current container. And nerdctl also provides a bunch of other features like nerdctl dash namespace for namespacing containers like Kubernetes. And unlike Docker, nerdctl supports connecting the container to multiple networks at once, like nerdctl run dash net equal foo dash net bar to connect the container to network foo and network bar at once. And unlike Docker, nerdctl supports AppArmor for rootless containers, but you still need a sudo command to initialize AppArmor for rootless containers. And nerdctl also supports FreeBSD containers using jail, and also supports Windows containers. The next topic is FAQs about nerdctl. The first one is why not use CTR? So CTR is a CLI program included in Control-E, and CTR is often misbelieved to be the standard CLI for Control-E, but it's not true. CTR is just a debugging tool written for Control-E developers. So CTR is not made for users, and CTR lacks lots of high-level features that are present in Docker and nerdctl, such as exposing pods with nerdctl run -p, and also nerdctl run -restart equal always to enable restarting. And CTL also lacks support for .docker/config.json and Docker credential helpers like Docker credential ECR logging. And CTL also doesn't support reading logs of background content, but nerdctl supports nerdctl logs for reading logs of background containers. And there's also CRI-CTL. CRI-CTL is similar to CTR, but the API is different. So CRI-CTL uses Kubernetes CRI API, and on the other hand, CTR uses the native API of Container-D. And nerdctl uses the native API, nerdctl doesn't use the CR API because the CR API is solely made for Kubernetes and has very tight scope compared to the native API of Control-G. And it's hard to modify the CRI API to support new features. And so implementing new features isn't always hard, but it's often hard to go through the full Kubernetes enhancement proposal processes to do negotiation for modifying API. And why not Docker? Because Docker doesn't use the functionality API for image management, and Docker can't be used for experimenting new features like discipline. And the release cycle of Docker was very slow in the past. Docker version 19.0.3 was released in 2019, and Docker 20.10 was released in the end of 2020, and there was no release in 2021 and 2022, and we just saw Docker version 23 last month. So that's why we had to create nerdctl so that we can do experiments for images by ourselves. But we are not trying to defeat Docker with nerdctl, and actually experiments in nerdctl are being ported to Docker too. So like Raspberry is already there is already work in progress to support Raspberry in Docker version 24. And why not Postman? Why not Cryo? This is because Postman doesn't work as a Kubernetes runtime, and Cryo doesn't work with Docker like CLI. So you could argue that Postman can be partially used as CLI for Cryo, like Postman ps-external to show Cryo containers in the Postman CLI. But still, Postman and Cryo are separate container engines. And on the other hand, Containerd covers the both of Kubernetes and nerdctl CLI. And the last topic is how to get started with nerdctl. So we have released it in github.com/containerd/nerdctl. And we have nerdctl-full-version-linux-md64-z. This archive contains all dependencies like Containerd and Rusty and other plugins. And you can run sudo systemctl enable now Containerd to enable Containerd for the rootful mode, or you can use containerd-rootless-setup2.sh install to install Containerd for rootless users. And if you use macOS, you should try Dima. Dima stands for Linux machine, but Dima was originally designed as nerdctl machine, but we extended the scope to support other workloads too. So the project is now called Dima, but Dima was originally made for running nerdctl on macOS, and now Dima is now a CNCF project, and Dima is very similar to Docker Desktop or Docker Machine or Postman Machine, and we have also automatic port forwarding and host file system sharing with SSHFS or BART IO 9P or IPFS, and you can use brew install daemon to install daemon into your Macintosh, and you can use alias nerdctl equal nerdctl.daemon to run nerdctl on Macintosh. And nerdctl is also included in AWS Pinch and Korima and Razor Desktop. All these projects are based on daemon too. And here's the wrap up of my talk. So nerdctl stands for Conchida-D CTL, and it's made for facilitating new experiments in the Conchida-D platform, like Lazy Print and critical image distribution and encryption, Tiny, and real read-only mount, and rootless continuous without Slirp, and interactive debugging of Dockerfiles, and more. And we have Slack channel at slackcnc.io. And my slides are available at slideshare.net. I paste the link. That's all of my talk. Thanks.
Thank you, Akihiro. That was great. There's one question in the chat. Which lazy pull formats are supported without Fuse?
Yeah, so OverlayBD uses block devices. So OverlayBD is free from Fuse. And I think Nydus is also free from Fuse when Nydus uses EEROFS.
All right, thank you. I'm not seeing any more questions in the chat.